So the recap is that we started off with oxidation states, and I explained the first thing I explained was that what is oxidation state and how it's different from a charge. So I told you that you've got all sorts of molecules. You've got ionic compounds where they actually have a charge, where someone actually loses an electron and someone else actually gains. There's an atom that actually gains electrons. So you had these ionic compounds where the charge is the oxidation state. But then I told you that there were covalent molecules where the electrons are not actually gained, but they're shared. And then I told you about the concept of electronegativity, and I told you that even in a covalent compound, the electrons are not perfectly shared. One of the atom would be pulling the electrons slightly with more strength, which is why the electrons would be closer to it. So since in redox reactions, we just want to know who's gaining electrons and who's losing electrons. So I'm going to treat a covalent molecule as if it's ionic. I'm going to treat it as if the two electrons have been gained by Cl, and I'm going to give it -1 charge, and H would be +1. And then we talked about that we can't really do this for every molecule because it's going to be very time consuming. So you have a simple table of finding out what the oxidation states of different elements are, and that table is that group 1 is always +1 in compounds, group 2 is always +2, and then you have group 3, which is +3. And then you have got a bunch of transition metals and they have variable oxidation states. Oxygen is -2, hydrogen is +1, and you've got fluorine, which is always -1. And we learned how to calculate oxidation states of different elements. So just very quickly, I'm just going to do a few more questions, and we're going to try and learn the. Just 1 second, let me leave a message. That's okay. So we're just going to try and do a few more questions, just very quickly. So for example, this one, let's try and figure out the oxidation state of the elements in this compound. So in this one, we know that H is +1. I mean, we know that oxygen is -2 because the table tells us H is +1. We know that, but we have no idea what P is. So the P over here is unknown. So we're not sure about P. So it's +1. So what you're going to do is that hydrogen is +1, so that's +1 times 4. Phosphorus, take that as X, and you don't know what that is, so it's going to be multiplied by 2 because there are two phosphoruses. And then oxygen is -2, and that would be multiplied by 7. And you're going to add up everything, and you're going to make it equal to the total charge, which is 0 in this case. It's a neutral molecule. So can anyone solve this and tell me what the value of X is? Like, what would be?
5.
It's coming out to be 5. So similarly, you can find oxidation states of pretty much all the unknown elements. If you talk about N2H5, just a second. So if you talk about N2H5, now N2H5 has an overall charge of +1. So they've given the overall charge. So that means the individual charges, they must add up to be equal to the overall charge. So N is unknown, so that's X, and there are 2 nitrogen, so that's 2X. And there are 5 hydrogens, so that's 5 times +1. And you add up all the charges, and they should be equal to +1. So 2x would become equal to, I think, -4, and x would come out to be equal to, it would come out to be equal to -2. So that's one thing. And that's how you're going to figure out the charge on the molecule, on the elements, on different elements. Just let's try just do one more. C2O4 2-. I gave this as an assignment, I think. Yeah, I did. C2O4 2-. So carbon is going to be taken as X, and there are 2 of them. Oxygen is -2, so that's times 4, and the whole thing would be equal to, it will be equal to -2. And so 2x would come out to be equal to what, plus 8 minus 2? So x would come out to be equal to 3. So x comes out to be equal to 3. So that means carbon has an oxidation state of plus 3 over here. So the point is that you can find out oxidation states of a lot of elements this way. Even though the oxidation states are not provided for all elements, by just knowing a few oxidation states of a few of the elements, you can pretty much find the oxidation states of all the other elements. Now, the next thing that I'm going to talk about is what do you do when you have oxidation states, and why are you looking for oxidation states? The reason we were talking about oxidation states was this reason over here. It was reduction and oxidation. I told you that whenever you see that the charge or the oxidation state increases, that means there's oxidation happening. That means there's a loss of electrons. And whenever you see the charge decreasing, that means there's a gain of electrons. Like if something goes from plus 6 to plus 7, that means it lost one electron. If the charge reduces, that means reduction is happening. If something goes from plus 2 to minus 8, that means reduction is happening. So we're gonna learn about this, and we're gonna practice this first. So there might be questions over here. Just one second. As let's so the oxidation states are already provided over here. Can anyone tell me which one out of these? And let me just quickly copy this. I'm going to take this on the board. One second. So let's talk about this one. So can you tell me which of the elements is getting oxidized?
Zinc.
Okay, so it's obviously zinc that's getting oxidized because the charge is increasing. It's going from 0. So it's 0 over here, it's going to plus 2. So that means it lost 2 electrons, right? And what's happening to silver? Its charge is decreasing. It's going to 0. It was originally plus 1. So that means it reduces. So reduction is happening and it's gaining 1 electron. So it gains exactly 1 electron. So that's what's happening over here. Now, whenever you see an equation that's a redox equation, which you have in front of you, is this clear to everyone? Costa, is this clear? Is this clear to everyone? Anna, Alicia, Ahmed?
Yes.
Okay.
Yes.
Okay, so there's oxidation and there's reduction, and both things would happen together. So this one was oxidation, charge increases, charge reduces, that's reduction. Now, the thing with this is, and we're going to talk about balancing redox equations. Now, when you talk about balancing redox equations, you balance the number of atoms. The number of atoms on the right side and the number of atoms on the left side, they must be equal. Now, this equation is already balanced. I mean, atom-wise, it is balanced. The zinc, there's one zinc, there's one zinc over here. Well, there's one silver, there's one silver. So, atom-wise, the equation has to be balanced. But in redox reactions, the number of electrons gained and lost, they must be balanced as well. They have to be, gain and lost must be equal. So the two must be equal, which is not the case over here. That you can see that zinc is losing 2 electrons, but silver on the other hand is just gaining 1 electron. So we have a problem at our hands that zinc is giving silver 2 electrons, but silver is only gaining 1 electron. So to balance the number of electrons, what I'm going to do is I'm going to multiply zinc by 2. That if I have 2 zincs, sorry, not zinc, 2 silvers, then the number of electrons gained would become 2 as well. So now the number of electrons that are lost and the number of electrons that are being gained, they have now become equal. So is this clear to everyone?
Yep.
Okay, so
Yes.
okay, so remember this, that in a redox reaction, I mean, it's way more important. I mean, you have to balance the number of atoms. I mean, the number of atoms on the left side and on the right side, they must be equal. But more importantly, the number of electrons that are being lost and the number of electrons that are being gained, they must also be equal. Uh, so if zinc loses 2 electrons, then you have to multiply silver with a number so that the number of electrons gained also become 2. And we can try this on another one. Okay, we can start off with simple ones. Just a second. I said let's try on this one now. Okay, let's try and balance this one. Take another simple equation. I said, so quickly tell me who's losing electrons, who's gaining electrons, which one is getting reduced?
Iron.
Okay, so Fe's charge reduces, so that means it gains 2 electrons, right? And Al's charge is increasing, so that means it lost electrons and lost exactly 3 electrons. So think of a number that I would multiply both with so that the number of electrons gained and lost, they become equal. What should I multiply this with? And what should I multiply this with? So that the number of electrons, they become equal. Gained and lost, they become equal. What would be that number? I mean, think of two different numbers actually. Well, what would it be? Any guesses?
2 with 3.
I mean, this one should be multiplied by 2. So multiply this by
Yeah.
2 and multiply this by 3. So that basically means you need to double the aluminiums. So if you have 2 aluminiums, that would automatically mean the number of electrons lost would be 6, right? And if you multiplied this by 3, that means you should have 3 Fe's. If you have 3 Fe's, the number of electrons gained would also become 6. So now the equation is balanced. And the number of electrons, so this redox reaction is now completely balanced. So is this clear to everyone, this part?
Yes. Yep.
Okay. So now the charges were given over here. Now we're going to move to, and we're going to try and do the same thing exactly, except that the charges would not be provided. So let me just quickly copy so that you're not able to see. I mean, there's a balance equation. Just give me 1 second. Let me copy the equation first. Okay, just give me 1 second. I'm trying to copy that. So it's Cr2072 minus, and it's reacting with HNO2, and there's acid, so that's H plus one ions present, and the products are Cr3 plus, and the other product is NO3 minus 1, and you've got water as well. Okay, so just 1 second, let me show you the equation. So here's the equation. So now we're going to try and do the same thing, except that the individual charges are not provided. So that's your equation now in front of you. The first thing is you would have to find all the oxidation states. So can anyone tell me what the oxidation state of Cr over here? Can you try and calculate this and tell me what Cr is? I mean, O is -2, obviously. So we know that O is -2. What is Cr? I mean, take it as X.
It's 6.
Okay, so it's coming out to be 6. So the two Crs, there's 7 oxygens, so that's -2 times 7. And the total charge must be equal to -2 because it's an ion. So if you solve this, I mean, the total charge is -2. So that's given over here. So you solve this, and when you solve this, x would come out to be equal to plus 6. So that means one of the CRs is plus 6. Similarly, can you try and find, I mean, you know what H is? That's plus 1. You know what O is? That's minus 2. Take N as X and try and figure out what N would be.
It's 3.
Okay, so you're getting 3. So it's plus 1 plus X, and oxygen is minus 2, and there are two of them, so that's minus 2, and the total charge is 0. You solve this, and this comes out to be 3. So the only difference compared to the previous one is that you have to find the oxidation states yourself. H is obviously plus 1. Cr, the charge is already given, that's plus 3. Can anyone tell me what N is over here? I mean, O is minus 2. What is the oxidation state of N?
5.
5.
Okay, so this one is 5. And you've got, I mean, H is plus 1, so we already know that, and O is minus 2. So that's the additional step. You figured out the oxidation states of all the elements in the equation. Can you now identify which one is getting reduced? Whose charge is decreasing out of all the elements in this reaction?
Chromium.
Okay, so chromium is true. Chromium is plus 6, and it goes all the way to plus 3. So it gains exactly 3 electrons. And we're talking about one chromium, right? One chromium gains 3 electrons. This is not balanced right now. And remember, oxidation state is for one of the atoms or one of the elements, not of two CRs together. So CR goes from plus 6 to plus 3. So one of the CRs goes from plus 6 to plus 3. So that means it's gaining 3 electrons. And which element is getting oxidized?
Nitrogen.
Okay, so you've got nitrogen over here, which is going from plus 3 to, and it's going all the way to plus 5. So that means it lost exactly 2 electrons. So think of a number that you're going to multiply both with. We just did something similar, which was that you multiply this by 3, which means that you should have 3 nitrogens, right? So if you want 3 nitrogens, that means this entire molecule should be multiplied by 3. I mean, you can't change the formula. I mean, the whole molecule needs to be multiplied by 3. And there should be 3 nitrogens over here as well. So that means this entire ion should be multiplied by 3. And chromium is gaining 3 electrons, so that means it should be multiplied by 2, so that the number of electrons lost and gained, they become equal. So there should be 2 chromiums. So there are 2 chromiums already over here. So there should be 2 chromiums over here as well. So that's, you multiply that by 2. So this part is balanced. Is this clear? The number of electrons gained and lost are now equal. So is this clear?
Yes.
And so this part is exactly the same as what we were doing over here, except that it's slightly more complicated and you have to find the oxidation states first. The rest is, now the two things that are still unbalanced, the H and the water molecules. I mean, you put numbers next to the ones that I've put boxes with, so that part is balanced. Now the rest of the equation would be balanced the usual way. The only thing is, just don't change these numbers, because if you alter them, the number of electrons lost and gained, they would become unbalanced again. You don't want to do that. So you're going to, so don't touch this 3 or 2, or I mean, there's a 3 and 1 over there. So you just have to balance it the usual way, count the number of oxygens. So that's 6 over here. Yes.
How is nitrogen balanced?
I mean, how many nitrogens do you have? Like in this molecule, there's only 1, right? You're talking about the electrons?
Yes,
You're talking about the electrons or the atoms?
the electrons.
You see, nitrogen, what charge did nitrogen had? It had plus 3, right? what charge did nitrogen have over here? It was +5. So if something goes from +3 to +5, that means it lost 2 electrons, right? So, and chromium was gaining 3 electrons. Chromium was +6, and over here chromium was +3. So if you go from +6 all the way to +3, that means you're gaining 3 electrons. So I multiplied this by 3, and I multiplied this by 2, so that the number of electrons lost and gained must be equal. Now, what I mean by multiplying by +3 is that I should have 3 nitrogens, right, over here. So the formula has 1 nitrogen, so I multiplied the formula with 3. So I have 3 molecules now. So I've got 3 nitrogens, right? And if I have 3 nitrogens on this side, there should be 3 nitrogens on this side as well. So the formula had just 1 nitrogen, so I multiplied this by 3 as well. France, is this clear?
Yes, sir.
And for chromium, I was multiplying it by 2, which meant that there should be 2 chromiums. So there were 2 chromiums already in the formula, so I didn't touch that. I didn't multiply it with anything. And there was only 1 chromium over here, so I multiplied it by 2 because I wanted 2 chromiums so that the number of electrons gained, they become equal to 6. So this part, the part that's in the boxes that's already balanced, I'm not going to touch them, because if I touch them, the number of electrons gained and lost, that would no longer be it would no longer be balanced again. So the only thing left is I need to just balance the water and the H plus one, and I'm going to do it the old way, which is that I've got 7 oxygens and I've got 6 oxygens over here. So that's, what's 7 plus 6? That's 13. So I've got 13 oxygens on the left side. So there should be 13 oxygen atoms on the right side. So that's going to be 9, and so there should be 4 H2Os. So there have to be 4 H2Os so that you have 13 oxygens, 9 already over here, and there would be 4 water molecules, so that's 4 oxygens. So I have 13 oxygens on the right side, and I can balance the hydrogens. How many hydrogens do I have? That's 8 over here. So what I can do is there's 3 already over here, so this would be 5. So the hydrogen is also balanced. So the rest of the atoms would be balanced the old-fashioned way. So is this clear to everyone? Mahad, is this clear? Anna, Zebi, is this clear? Kosa, is this clear?
Yes.
So let's try and do a similar question, and let me just copy one more question. 1 second. So the question is, it's IO4 minus 1, and it's reacting with BH3, and they're reacting to produce I minus 1 plus B4 and plus H2O molecules. So I've copied it. Here's the equation. So here's my reaction. Everything would be done the same way. The first thing is you have to figure out the oxidation states. Can anyone tell me what the oxidation state of I over here is? I mean, O, you know, that's -2. Calculate the oxidation state of I, which is the unknown. O is -2, so that's -2 times 4. The individual element charges must add up to be equal to, I mean, IO4 has a charge of -1, so they should add up to be equal to -1. And if you solve for X, it would come out to be equal to +7. So I over here is +7. Okay, is this clear?
Yes.
I said, what is the oxidation state of P over here? In pH3, can you?
-3.
Yes, that's -3 because H is +1. I mean, you solve it the same way. P is unknown X, H is +1, so that's +1 times 3, and everything should add up to be, it's a neutral molecule, so it should add up to be equal to 0. And when you do that, when you do that, it would be x would come out to be -3. So the charge for I is already there, so that's -1. Uh, any neutral element, that would be 0. I mean, P doesn't have a charge, so that's 0. H is +1, and O over here is -2. So we have the charges of all the elements, and what we need to do now is, I'm going to rub this off. So what we need to do now is balance the number of electrons that are lost and gained. Who's getting reduced? And how many electrons is it gaining? Reduction. Okay, so you have I that's getting reduced. Its charge is decreasing from +7 to -1. That means it gains a total of 8 electrons. So you were going from +7 all the way to -1. So that's a difference of 8. So you're gaining 8 electrons. And the substance that's getting oxidized, that's phosphorus, I think, because it goes from +3 to +3 to all the way to 0. Not +3, -3. I mean, its charge is increasing, it's getting oxidized, so it lost a total of 3 electrons. So it's losing 3 electrons. And so if it's losing 3 electrons, what would I multiply? What would be the quantity of each of the elements? What would I multiply this with, and what would I multiply this with? How can I make the number of electrons lost and gained equal? Anyone?
3/8 and 8/3.
Okay, so you multiply, you can make them 24. So multiply this by 8. So that means I should have how many phosphoruses? I should have 8 phosphoruses. And I multiply this by 3, so that I should have 3 iodines. Because each one would gain 8 electrons, so that would be a total of 24 electrons. So I'm going to multiply phosphorus by 8, which means I should have 8 phosphoruses. So this should be multiplied by 8. And I should have 8 phosphoruses, right? So, I mean, there are already 4 over here, so I just need to multiply it by 2 so that it could be made into 8. The other one, I should have 3 iodines. So I'm going to multiply this by 3, and I'm going to multiply this by 3 as well. So this part is now balanced. The only thing left is this water now. I'm not going to touch the part that's already balanced. The only thing left is water molecules. So let's do those water molecules. I mean, there are how many hydrogens? There are 24 hydrogens. So there should be 12. There should be 12 water molecules, so that you can have 24 hydrogens, and you can check the oxygens as well. That's 3, 4, 12 oxygens. So this is 12 oxygens over here as well. So now this equation is balanced. So there's reduction happening and there's oxidation happening. And this is now your balanced equation. You should know how to make this balanced equation. Is this clear as well to everyone?
Yes.
Yes.
Mariam, is this clear? Okay. So now similarly, there's another reaction. I mean, it's the same thing, nothing different. There's another reaction which is called a disproportionation reaction. What happens in a disproportionation reaction is, like for example, there's iodine. I mean, in a normal redox reaction, there's iodine gaining electron and there's phosphorus that's losing electrons. So they're two different elements, one gaining and one losing. In a disproportionation reaction, you have the same element gaining electrons as well as losing electrons, both at the same time. So let's see. For example, there's this one reaction. I mean, let me talk about disproportionation for a second. So this is a reaction where the same element gets oxidized and reduced so the same element gets oxidized and reduced at the same time. So that's what a disproportionation reaction is. So I'm going to talk about one such disproportionation reaction. This is something that you're going to study uh, in your inorganic chemistry class as well. So it's chlorine reacting with NaOH, and it ends up forming NaCl. It forms another compound which is NaClO3, and it forms water as well. So this is an example of a disproportionation reaction. Why? Because if you try and calculate the oxidation states of all the elements, you would notice that nothing is happening to the oxidation state of all the other elements except for one. Cl over here is 0. Na is +1. O is, I mean, this is, we already know that. O is -2. Why do we know Na? Because Na is in group 1. It's always +1. And H is +1. So we already know this. Na is +1. And Cl is -1. And then you have NaClO3. So how do you find that? Na is +1. Cl, you're not sure. And oxygen is -2 times 3. And the overall molecule is 0. It doesn't have a charge. If you try and solve for x, it would come out to be -6 goes to the other side, and then so it's going to become +5. So that means Cl over here is +5, O is -2, Na is +1, and then you've got water where H is +1 and O is -2. So here's this reaction that's happening. And is the first part clear? Oxidation state, TK, we found the oxidation state. Now, so tell me, who's getting reduced and who's getting oxidized?
Chlorine.
And both things are happening to the same element. Like Cl goes from 0 all the way to -1. So its charge decreases. It's getting reduced. It gains exactly how many electrons? It gains exactly 1 electron. But then there are other Cl atoms that are getting oxidized. I mean, they go from 0 to +5. That means they lost 5 electrons. Right? So this is a disproportionation reaction. Like you have a bunch of Cl atoms. Some of them, they go into Cl-1, they become Cl-1, so they gain electrons, they undergo reduction. While you have the other ones which are losing electrons to form Cl +5. Okay, so is this clear?
Yeah.
Okay.
Yes.
So this is known as a disproportionation reaction. You're going to do the same thing exactly. How do you balance that? Uh, so Cl is losing 5 electrons. At the same time, there's another Cl that's gaining 1 electron. So I need to multiply the first one with 5, this one with 5. So that means this Cl over here, there should be 5 of them, right? And that would balance the number of electrons that are being gained and that are being lost. I mean, there should be 1 Cl plus 5. I mean, there should be 1. You don't write 1. Uh, so I need to multiply this by 1. I mean, I need to keep it 1. The other Cl that is gaining electrons, I need to multiply it by 5 so that the number of electrons that are being gained and the ones that are being lost, they become equal. So it's going to be 5 ratio 1. And since the starting point is the same thing, I mean, so that how many Cls total you have? You've got 5 that are gaining 1 electron, and you've got 1 that's losing 5 electrons. So the total number of Cls is 1 over here and 5 of them over here, so that's 6. So you're at the starting point, you had 6 Cls. So this part is also balanced now. Is this clear?
Yep.
ठीक है, it's clear to everyone. So, and the very last part is you balance I mean, these things. How many NAs do you have? You've got 5 plus 1 over here. So that is a total of 6 NaOH. And you can balance H as well. Over here, you've got 6H. So there should be 3 water molecules. So I'm just going to give you some homework on this. You need to try and balance these equations. So let me just copy these equations on the board. Do you just give me 1 second? And try, and these are your questions. So it's P4 plus NO2 minus 1, just writing questions, just a second. Plus OH minus 1. H2 PO2 minus 1. Then there's MnO4 minus 1. Plus OH minus 1, and then it's MnO2 plus H2O. 1 second. Plus you have H2O. Let me try and find a few more equations. Okay, so this one, number 3, is IO3 minus 1. Plus H2O. Okay, so these 3, I'm just taking a snapshot and sending it to you. Try and balance all these 3 equations. Okay, and send it to me. I'm putting it up in Google Classroom. Okay, let's talk tomorrow. Try and solve these 3. Okay, sending it on WhatsApp as well. So okay, let's continue tomorrow then.
All right, thanks.
Okay, take care, everyone. Allah Hafiz.
Yeah.